What if the periodic table had never been created? Imagine a world where chemistry was a chaotic labyrinth, where each element was an isolated island with no apparent connection to the others. A world where the development of new medicines, materials, and technologies would be drastically slower and uncertain. Seems unthinkable, doesn't it? The periodic table, that seemingly simple grid that adorns laboratory walls and textbooks, is much more than a list of elements. It is a map, a guide, a universal language that organizes the foundation of matter and reveals the secrets of the universe. It revolutionized chemistry, transformed physics, propelled biology, and shaped the world we know. But how did this fundamental tool emerge? Who was the visionary who dared to organize chaos and find order behind the apparent randomness of elements? To answer this question, we need to go back in time to 19th century Russia and meet a man named Dmitri Mendeleev. Mendeleev, a Russian chemist with a brilliant mind and tireless passion for science, was obsessed with finding a pattern, a logic that would unite the known elements. In 1869, he struggled with the task of writing an inorganic chemistry textbook. The task was Herculean: how to present a set of apparently disconnected facts in a coherent and understandable way. Frustrated with the lack of organization, Mendeleev had a bold idea. He wrote the name of each of the 63 elements known at the time on separate cards, along with their atomic and chemical properties. He began organizing them, moving them from side to side, seeking a pattern, an order. At first, chaos. The cards scattered over the table, a confusion of symbols and numbers. But Mendeleev persisted, driven by a deep intuition that the answer was there, hidden somewhere. He realized that when organizing elements in ascending order of atomic weight, similar properties began to repeat at regular intervals. It was as if the elements formed families, groups with common characteristics. Excitement seized Mendeleev. He felt he was about to unravel one of nature's greatest mysteries. He worked feverishly, moving the cards, adjusting each element's position, until finally, order emerged. The periodic table began to take shape. Rows and columns aligned, revealing surprising patterns. But Mendeleev didn't stop there. He realized there were empty spaces in the table, places where unknown elements should fit. With visionary boldness, Mendeleev predicted the existence and properties of elements that had not yet been discovered. He not only organized what was already known, but also predicted chemistry's future. The publication of Mendeleev's periodic table was a watershed moment in science history. It provided an organizing structure for studying elements, allowing chemists to understand their properties and predict their behavior. The table revealed that element properties were not random, but determined by their atomic structure. It allowed scientists to create new materials with specific properties, driving the development of new technologies. But how did the periodic table transform chemistry study and pave the way for advances in other areas of science and technology? Get ready, because in the next block, we'll dive into the periodic table's profound and lasting impact on the world of science and technology. Without the periodic table, imagine a chemist's arduous task trying to understand an element like oxygen's behavior.
He would have to study it in isolation, without any reference to elements with similar properties, like sulfur or selenium. Each experiment would be a shot in the dark, each discovery a stroke of luck. The periodic table provided context, connection between elements, transforming chemistry study into a logical and predictable science. Think about ammonia synthesis, a fundamental process for fertilizer production that feeds billions of people. Without understanding catalytic properties of transition elements, like iron, this process would be impossible. The periodic table guided scientists in searching for efficient catalysts, enabling large-scale ammonia production and, consequently, increased food production. Or imagine developing new medicines. Understanding structure and properties of organic molecules formed by carbon, hydrogen, oxygen, and other elements is essential for designing effective drugs. The periodic table provides the foundation for this understanding, allowing chemists to create molecules that interact with specific biological targets, fighting diseases and saving lives. The periodic table not only organized existing knowledge, but also predicted chemistry's future. Mendeleev left empty spaces in his table, predicting the existence of elements not yet discovered. And he not only predicted their existence, but also their properties. He predicted, for example, the properties of gallium, germanium, and scandium, elements discovered years later that fit perfectly into spaces predicted by Mendeleev. The discovery of gallium in 1875 was impressive proof of the periodic table's accuracy. Mendeleev had predicted that an element with aluminum-like properties would exist and would have an atomic weight around 68. He called it eka-aluminum. When gallium was discovered, its properties and atomic weight, 69.7, corresponded almost perfectly to Mendeleev's predictions. The periodic table also propelled new technology development. The semiconductor industry, which is the foundation of modern electronics, depends on understanding properties of elements like silicon, germanium, and gallium. The periodic table allowed scientists to manipulate these elements' properties, creating electronic devices increasingly smaller, faster, and more efficient. Think about smartphones we use every day. They contain dozens of different elements, each with a specific function. The screen is made of indium tin oxide, the battery is made of lithium, cobalt, and nickel, and circuits are made of silicon, gallium, and other semiconductor elements. Without the periodic table, developing these complex devices would be unthinkable. But the periodic table's impact goes far beyond chemistry and technology. It also influenced other science areas like biology, medicine, and physics. In biology, the periodic table helps understand living beings' composition and different elements' roles in biological processes. Carbon, for example, is life's fundamental element, forming the backbone of organic molecules. Nitrogen is essential for protein and nucleic acid formation. Phosphorus is an important component of DNA and ATP, the molecule that stores energy in cells. In medicine, the periodic table is fundamental for developing new medicines and treatments. Many drugs contain metallic elements, like platinum, used in treating some cancer types. Understanding radioactive elements' properties is also essential for radiotherapy, a treatment that uses radiation to destroy cancer cells. In physics, the periodic table helps understand matter structure and interactions between subatomic particles.
Nuclear physics, for example, studies atomic nuclei structure and nuclear reactions. The periodic table provides a map of atomic nuclei, allowing physicists to understand their properties and predict their behavior. Without the periodic table, chemistry study would be like navigating an ocean without a map or compass. It would be a labyrinth of disconnected facts without any order or logic. The periodic table provided the organizing structure that allowed chemistry to become a modern and predictable science, driving advances in all areas of science and technology. But what would our world be like without the periodic table? How would our daily life be different? Get ready, because in the next block, we'll explore the periodic table's profound and comprehensive impact on society and our daily life. You'll be surprised to discover how this fundamental tool is present in everything we do. Imagine a world without plastics, without packaging that protects our food, without light and resistant materials that compose our cars and planes, without computers and smartphones that connect us to the world. Plastics, derived from petroleum and other elements organized in the periodic table, have become omnipresent in our daily life. Without the table, chemistry necessary to create these versatile materials would be a minefield of trial and error, with unpredictable results and slow development. Think about medicines we take when sick. Most modern medications are complex molecules synthesized in laboratory from a variety of elements. The periodic table is the map that guides chemists in building these molecules, allowing them to create drugs that fight diseases and relieve suffering. Without the table, developing new medicines would be a much longer, expensive, and uncertain process. From antibiotics that combat bacterial infection to painkillers that relieve headaches, the periodic table is present, silently, behind the scenes of our health. Consider cosmetics we use to care for our skin and enhance our beauty. Creams, lotions, makeup all contain a variety of chemical compounds, carefully formulated to protect, moisturize, and beautify. The periodic table is the knowledge foundation that allows chemists to create these products, ensuring they are safe and effective. Imagine a world where choosing simple lipstick was a risky bet with unknown ingredients and potential side effects. Look around, observe electronics that surround us. Smartphones, computers, televisions all depend on semiconductors, materials that conduct electricity under certain conditions. The periodic table is the guide that allows scientists to manipulate these materials' properties, creating electronic devices increasingly smaller, faster, and more efficient. Without the table, the digital age we live in would be unthinkable. Global communications, information access, industrial automation, all this would be drastically affected. Imagine food production. Fertilizers, which increase crop productivity, are chemical compounds based on nitrogen, phosphorus, and potassium, essential elements for plant growth. The periodic table is the map that allows farmers to understand plants' needs and provide adequate nutrients. Without the table, food production would be much lower, leading to scarcity and hunger in many parts of the world. Think about lighting. Incandescent, fluorescent, and LED lamps depend on different elements and chemical compounds to generate light. The periodic table is the guide that allows scientists to create increasingly efficient and durable lamps.
Without the table, our nights would be much darker, and our homes less safe. Civil construction would also be profoundly impacted. Concrete, one of the world's most used construction materials, is a mixture of cement, water, and aggregates. Cement, in turn, is a complex chemical compound produced from limestone, clay, and other materials. The periodic table is the map that allows engineers to understand concrete's properties and build safe and durable buildings. Without the table, our cities would be very different, with more fragile and less resistant buildings. Even art would be affected. Paints, pigments, and materials used by artists depend on a variety of elements and chemical compounds. The periodic table is the guide that allows artists to create vibrant and lasting colors. Without the table, artistic expression would be limited, with less intense colors and artworks more prone to fading over time. In a world without the periodic table, daily life would be harder, more dangerous, and less comfortable. Technology we take for granted would disappear, medicine would regress to archaic practices, food production would be insufficient to feed the world population. The periodic table is not just a laboratory tool, it is a fundamental pillar of modern civilization. But the periodic table's story doesn't end with Mendeleev. The discovery of new elements and increasingly deep understanding of atomic structure continue to expand our knowledge and drive new technologies. What is the periodic table's future? What new elements will be discovered? And how will these elements transform our world? Discover in the next block, where we'll explore the periodic table's future and its potential impact in the coming decades.